Okay, so I'm just constructing one of the molecules. This is 5-REY ligand that I'm constructing. So this is one that I hope you've already done. So let's see if I can get it right. There we go. And of course, I just need one more bond. Now, the problem that I've got with this at the moment is that it doesn't have the right atoms. And so I just need to make sure that it's got the right atoms at two places. And so there should be a nitrogen over here, nitrogen over there, and this is a carbonyl, not a CH2. Okay, so there I have constructed one of the molecules, 5-REY. And of course, what I want to do is I want to submit it to the cluster. But of course, what we've got to do is we've got to make sure that all atoms are present. And so what I'm going to do is make sure that we've got explicit hydrogens. And so that is fully sorted. But of course, what we need to do as well, we can clean it in 3D. Hang on, sorry. We can clean it in 3D. You can maybe let's go back to 3D. My apologies, clean in 3D. So here's the three-dimensional molecule. And what is important on this is we've got a 7-membered ring in this. So before I do anything on this, I think the best thing for me to do is a conformational search. So we might have the wrong conformation. We might not have a low energy conformation. So let's do on calculation. Let's calculate conformers. And I'm really only interested in the lowest energy conformer. So I'm just going to check that button over there. And let's, you can increase these numbers to make a longer search. You'll probably get a better conformation. We'll speak about conformation tomorrow. And that was very quick, but it seems to have a very nice, we seem to have a reasonable conformation over there. Perhaps not perfect. Okay. But here we go. Here it is. And I can go and file save all. Let's save it as a Gaussian input file. And this is 5-REY. And I'm going to call it .com. Okay, so here's 5-REY ligand. And if I can now edit that, go to the documents and 5-REY ligand, here we go, here it is. Edit. You'll see that at the top, it's exactly the same as we had before. But yesterday, we just made 2 changes to this. And today, I just want to speak to you about another 2 changes beyond what we did yesterday. So I hope that you were able to firstly make it workable on the cluster by going, making the mem at least, well, not too much, 6 gig, and percent in proc shared is 8, must have 8 on that. So that when we submit to the cluster, it goes 8 times faster. I hope that you did that, but there are a couple of other things that I want to do. Okay, so you can have a look at, I want to put a line and a second line, and I'll tell you a bit about it. Some of you are not going to be just using modeling in the case of protein-ligand interactions, which is our concentration in this course. Some of you will be interested in the properties of molecules. And so you might be interested in molecular orbitals, for example. So what is nice is to get a little bit more information from Gaussian saved as a separate file. And so you can give it the name, and it's %check. It's a checkpoint file. And this is 5-REY ligand is the name of a file I wanted to create. But of course, instead of being a log file that it creates, I'm going to call it a .check file. So if you add that directive, if you run Gaussian, it'll create an additional file beyond the log file that we got yesterday, but an additional file. And that additional file, most importantly, contains molecular orbital information. So you will be able to look at your highest occupied molecular orbital, etc. So it's really, really important if you are interested in properties of your molecule to have that directive in the input file. That's the first additional change that I want you to be able to make. Okay. These two are really important because I won't let your Gaussian run if you don't have them on the cluster. I put checks and balances in to make sure you have them there. Otherwise, the cluster will say, no, you're trying to run it too slowly. Okay. But of course, this here, you don't have to have in. This is one that doesn't have a check in that I don't check for. But if you but make sure it's typed perfectly and make sure this is not a log at the end, not the same. It mustn't be the same file as a log file that will be produced. So you'll have 3 files to worry about. You'll have a com file, which is your input file, the log file, which is automatically generated, and this third file that we can direct for in there. Okay, right. Now, the final change that I want you to be aware of relates with our directive here. And everything that Marvin Sketch has put into the Gaussian file here is really nice. Okay, but I don't want to go into all this too much here in terms of what I want you to be concentrating on now. So all of this is absolutely perfectly right. But the most important things are, so the most important thing that we have here is that we have the word opt. And that word opt means that it's going to optimize your molecule. So after the hash, just leave a space, make sure there's a space after the hash, and just make sure that there is the word opt in here. That opt will tell you what to do. We can also do a vibrational analysis. You know, in infrared spectra, you've got vibrations. So for instance, if I also want to do a vibrational analysis, I would type the word frequency here. And that will make for a very long calculation. It's a very tough calculation to do frequencies. So I won't expect the results before tomorrow. So if I do an optimization, it will go quite fast, but a frequency will take that time again. So you've got a much longer calculation if you wanted to calculate the vibrations in a molecule. So opt and freak are ones. So you don't have to have this freak in, but it's good practice to do a vibrational analysis when you are doing calculations. And then finally, Gaussian does flavors of quantum mechanics. We have to tell it what flavor of quantum mechanics to use. And so I'm just going to repeat the flavor that Marvin Sketch had. And they had B3 LYP, which is a hybrid density functional method. And attached with it is a basis, 6-31 G, and with brackets D. And that has to be typed exactly so that everything, so just be very careful that it is typed exactly like that. So it's B3L, not B31. It's B3LYP, and it's 631 GD in terms of the basis. So that is a flavor of quantum mechanics that we're asking Gaussian to use. Okay. So are you happy with these 2 additional changes? Be careful that you do not change other places in the file. And just, maybe I'll just alert you, see this 0 and 1? Okay, that 0 means that the charge in your molecule is 0. And the 1 means a multiplicity. It's about in terms of your electrons. And so are they paired or unpaired? And here they're all paired, so the multiplicity is 1. I can go into it later. But please, if your Gaussian does not work, if you try and run and you get errors, it's very easy to send me an email and you can say, my username on the cluster is this, and the file name on the cluster is this file name. Please, won't you have a look at it and tell me what's wrong? Send me that email. I can go directly into the cluster. I can change to root. I can navigate to your folder. I can have a look at the file and try and figure out what it is. But please, there's so much on the cluster that if you do not tell me exactly what file to look at, there's no way I'm going to find it. There are millions of files on the cluster. You have to be very specific about exactly what file you want me to look at, or else I will not be able to find it. Okay. Right, so now I've got a new run, and I'm just going to save it where I've made those specific changes at the top. And now I have to go back to WinSCP and copy those to the cluster. Please make sure that you are on top of calculations. There will not be time next week to do these calculations. We won't be able to. You can imagine that if you have to wait an evening and you've got 5 calculations to do of these, you can't be doing them next week and getting a write-up together. You'll be needing to look at results. So make sure that all these calculations are done this week. Okay, so here we go. Let's copy that. So it's 5REY. I'm going to copy it onto the cluster. Okay, and so now I have 5REY is ready on the cluster. So I'm going to need putty. There's putty. Okay. Okay. Okay, let's just type. So the first thing I'm going to do here is I need this module add. So I need to type all of that. So one trick is that if you do have a mouse and you are using putty, if you select it and you just right click, it pastes what you select. So we've got to do that module add. And so now I can use Gaussian. Okay, I'm going to type ls just to see what I've got there. And that is fine. And then I can do sub G09. Hang on, maybe I need to see if anything's running first and to use the other queue. So there's a lot running on batch, and fantastic. I really like to see this, that we've got these ligands running. So that is really fantastic. So I see batch is a bit used, so I'm going to use a del at the moment. So I'm going to do sub G09, del, and it's 5REY, the 5REY, and I've got nothing else, so tab knows that it's that. Hang on, we mustn't have .com there. 5REY and 8. Okay, and so that is then going to create and then if I type qstat again, you can see that I've got a run now going on the del queue. Okay, but one thing I noticed when I typed ls is that my run from yesterday is now complete. Qstat is no longer running my run from yesterday, and I can see 5recligand.log over there. So what's interesting is that it's in a Gaussian output file format, and it's not in these nice formats, the MOL2 or PDB, that can be used everywhere. So the log is quite nice. Let's go here. I can copy the log. There's 5recligand. I can copy it. I think I'd already copied it to have a look at it earlier. Let's copy it across. So yes, I can copy it across. There are programs that will open the log. So I think I've asked you to look at Avogadro, to install Avogadro. Avogadro is really nice. It can open these log files. So, so let's see, which one is it? That's here we go. Here's the log file. It's coming up as a text document. Here's the log file. When you open an Avogadro, here is a very accurate, optimized version of a molecule. And you can see that lovely intramolecular hydrogen bonding arrangement between the OH that I've serendipitously managed to get. But there it is. There is your optimum geometry. So that's fantastic. You can open it. So Avogadro can open it. But it is still, and maybe you could use Avogadro to save it, but it's still not in a PDB format or a MOL2 format. So please, can I remind you that on the cluster, we always have this command Babel that takes the 5 words. So the first word is Babel. And of course, now, what type of input would we have? The input file would be a Gaussian 09, so G09. So you type -I for input, G09. It's a Gaussian 09 output format over there. And the name of the file is 5rec ligand.log. That was the Gaussian output. And I can go -output, and I'm going to call it a 5rec optimized. Let's give it a long name, which will cause trouble. I'll have to type lots and lots. So this was with Gaussian. Oh, hang on, I missed out the -O as a PDB, sorry. Okay, my terminal has crashed. Here we go. No, it hasn't crashed. It's just slow. The output tile I'm going to do is output as a PDB file. .pdb. And so this Babel input Gaussian 09, and that's a log file that was created from yesterday. Output is PDB, and it'll be optimized.pdb. Okay, so let's have a look at that. And it converts it to a PDB, and if I ls, you can see that I've now got a PDB. Here's my PDB, and it's useful elsewhere. Okay, the final thing that I want to do is, how do I know that that Gaussian run was perfectly successful? And maybe I should have done this earlier, is if I can find that log file that I've created across. Where's the text file? Here we go. Here's the log file. If you open it with Notepad++, this is what the log file that we created yesterday looks like. And you can see it's recognized, Gaussian recognized what we typed at the top yesterday. And then it puts out a whole lot of random stuff. You can see, as you go through it, you can see Cartesian coordinates. But what you need to do is you need to scroll right down to the end. If you scroll right down to the end of it, you'll see that right at the bottom of a file, it says normal termination of Gaussian 09. And it's really important to check that there is this normal termination and not an error. Because if there's an error, there will often be some information in this log file as to why there is an error. And remember, there are 2 ways in to open this log file. I opened this log file using Avogadro, and it rendered the log file as a beautiful, optimized molecule. But you can also open the log file with a text editor to get more information. And there's a lot of really, really good information that you can get from here, is that you see that there's been a correct termination. There have been no problems with the run. There's been no problems with the optimization. But there's also more information, like, for instance, over here. See this HF that I see over there? I know that the total energy for my molecule is -780.825451. That energy there, I could convert it to kilojoules or kilocalories, for instance. That energy there has been calculated at a very accurate quantum mechanical level of calculation. Okay, so please don't be afraid to dig through the rubbish, or not rubbish, the intense amount of information that comes through in a log file. Don't be afraid to sift through it, because there's often useful stuff that you can see in there. Okay. But of course, always scroll to the end and check that you've got normal termination of your Gaussian file. Okay. Are there any questions? Right. So if there are no questions, this is what you need to make sure you can do. Make sure that you have constructed all molecules, all 5 molecules. Please, if you're interested in looking at zinc, you could look at some other Yes? Question?
Just want to ask, if you convert the energy, the HF energy that you got using the Gaussian calculation, does it match the one we got yesterday using the XTB calculation?
No, it won't. It won't.
Similar.
And what's even worse, is if you've got another molecule that's totally different, it's very difficult to compare those energies to each other. The only place where we could really compare these energies is if we had 2 conformations maybe of the same molecule, or if we had a reaction taking place. We had the same number of atoms at the start and at the end. This energy is going to be very dependent in quantum mechanics on the electrons that were used to do the calculation. And you can imagine that if I did another molecule, it would have a different number of electrons, and so we wouldn't really be able to compare the energies. We'd know they were different because the energies in the nuclei were actually different to each other. Okay, so what I want to make sure is that for the 5 ligands you've got, you've constructed them, you've maybe done a conformational search in Marvin's sketch, you've submitted them on the cluster in exactly this way, and with at least 1 or 2 of them, you're creating this checkpoint file, because it'll be interesting to see tomorrow if we can have a look at that checkpoint file and see if we can see some molecular orbitals. Okay. If you're not happy, and some of you might not be happy, these 5 compounds are all known in terms of the coronavirus main protease. So if you're not happy, because these are known compounds, if you want to explore slightly different compounds, you can maybe go to zinc and see if you can find something that's similar to one of those compounds. Because we might find when we come to do binding to coronavirus main protease, we might find that something slightly different binds better, in which case you've got something new. It's not all that one needs to do in terms of trying to find something better, but it's a starting point. So you might want to be doing another compound in addition, or another 2 compounds in addition to these 5, where the new compound is slightly different to one of the 5 that I provided you. Okay. And a place to search for compounds is the zinc database. So just check your notes or email me if you really are struggling if you want to find another compound. But if you get another compound, it needs to be treated in exactly the same way. I'd like you to take that other compound. You could either optimize using XTB, or what you could do is you could submit it to Gaussian and get an accurate geometry from Gaussian. Okay. I want you to do that to get practice on Gaussian, or Gaussian or XTB in getting these optimized at the QM level. Okay. Any other questions? You're all happy with what I need you to do? Okay. You're all happy at the end how I used Babel to convert it back to a PDB? The beautiful geometry back to a PDB that can be used anywhere? Okay. Right. If there are no further questions, please note my email is... Yes, a question, good.
Oh yeah, just one question. I think I got lost somewhere. I wanted to ask, can we submit, like, let's say one person, can you submit like 2 or 3 calculations at the same time?
Of course. It's a queue. It's the first come, first served. So just see who's using it. If it's on the batch is full and there are too many runs going, submit to the DEL. But of course, what happens if both queues are full? You just carry on submitting. I think that we could have. I think that my limit is about 500 jobs in that queue.
Okay.
So you can add up to 500 jobs, and then we must just all wait. But
Okay,
please don't do 500 now, because if because
it's all right.
it'll slow down the whole cluster. But you can certainly 10 jobs is fine. Submit 10 jobs.
It's okay.
It's fine. And it's good to submit them now, because then by Friday, by Monday, they'll be totally clear, and we won't have stress next week of doing calculations, these long calculations. Okay. Any other questions? Okay. If there are no other questions, okay, then what I'm going to do, I just need to remember to upload this to YouTube. I think the other one is already nearly on YouTube already. So I'll upload this. And please, questions, you must email me. You must email. Okay, so I'm going to sign off at this point. Okay.